Basics of electrical machine. Electrical machines overview. Electrical machines are devices like transformers, generators, and motors that either convert electricity to mechanical power or vice versa. Transformers. A transformer transfers electrical energy between two circuits without changing the frequency, crucial for regulating voltage levels in power distribution. Generators. Generators convert mechanical energy to electrical energy using electromagnetic induction, vital for producing electricity in power plants. Motors. Motors convert electrical energy to mechanical energy, essential in applications from household appliances to industrial machines. Operational principles. The operation of these machines relies on electromagnetic principles, where electric currents and magnetic fields interact to produce or transform energy. Faraday's first law of electromagnetic induction states the following. An electromotive force is induced whenever a conductor is placed in a varying magnetic field. If the conductor circuit is closed, a current is induced, which is called induced current. Faraday's second law of electromagnetic induction states that the induced EMF in a coil is equal to the rate of change of flux linkage. The flux linkage is the product of the number of turns in the coil and the flux associated with the coil. The formula of Faraday's law is given below. This either happens when a conductor is placed in a moving magnetic field when using an AC power source, or when a conductor is constantly moving in a stationary magnetic field. As per the setup given below, Michael Faraday arranged a conducting wire attached to a device to measure the voltage across the circuit. When a bar magnet is moved through the coiling, the voltage detector measures the voltage in the circuit. Fleming's left-hand rule: if the thumb, forefinger, and middle finger of the left hand are stretched to be perpendicular to each other, as shown in the illustration at left, and if the forefinger represents the direction of the magnetic field, the middle finger represents the direction of the current, the thumb represents the direction of force. Fleming's left-hand rule is applicable for motors. According to Fleming's right-hand rule, the thumb, forefinger, and middle finger of the right hand are stretched to be perpendicular to each other as shown in the illustration at right. And if the thumb represents the direction of the movement of the conductor, forefinger represents direction of the magnetic field, then the middle finger represents the direction of the induced current. According to Maxwell's screw rule, if a right-handed screw is turned so that it moves forwards in the same direction as the conventional current, its direction of rotation will give the direction of the magnetic field. The right-hand thumb rule is also known as Maxwell's corkscrew rule. If we consider ourselves driving a corkscrew in the current direction, then the corkscrew's direction is in the direction of the magnetic field. Use of Maxwell's screw rule. It is used to determine the direction of the magnetic field around a straight current carrying conductor. It can be used to determine the direction of the electric current in a conductor if the direction of the magnetic field lines associated with the current carrying conductor is known.